Okay, in a previous video we started to look at the concept of rationalising the denominator when we are working with surds. And rationalising the denominator just means taking the surd, the irrational number, out of the denominator. We looked at some simple examples in that previous video. Here's some slightly more complex examples. First one, 6 over root 5 plus root 2. How are we going to rationalise that denominator? In order to do that, we need to reintroduce this concept. You might remember this one, the difference of two squares, which says if we take two numbers and square them and take the difference of the squares, so a squared minus b squared equals a minus b times by a plus b in brackets. Okay, so how can we use that to help us rationalise that denominator? Well, notice that down here we've got root 5 plus root 2. So if we were to multiply that by root 5 minus root 2, multiplied by root 5 minus root 2, then we've set up a difference of two squares. But of course, we can't just do that to the denominator, we have to do it to the numerator as well. So root 5 minus root 2. Okay, how does that pan out? Let's look at our denominator first. Difference of two squares, root 5 plus root 2 times root 5 minus root 2. So we're going to end up with root 5 squared minus root 2 squared, which is going to work out as 5 minus 2, which is going to give us 3. And in the numerator, we're going to have 6 times by root 5 minus root 2. And we're almost done. The only other thing that you would notice there is that you can cancel through because you've got a 6 and a 3. So you can cancel through there and you'd have 2 bracket root 5 minus root 2. Okay, let's have a look at our second example down here, where we've actually got surds in the numerator as well. We've got root 2 over root 6 minus root 3. But remember, what we're aiming to do here is rationalise the denominator. So we're only looking to take the surds out of the denominator here. This one doesn't worry us. Again, we're going to use difference of two squares. So we're going to multiply root 6 plus root 3, because then I've set this up. But of course I have to do the same to the numerator as well. Root 6 plus root 3. How does that one pan out? Okay, 6 minus root 3, root 6 minus root 3 times by root 6 plus root 3. Difference of two squares means we're going to end up with root 6 squared, which is 6, minus root 3 squared, which is 3. 6 minus 3 equals 3. See how difference of two squares makes us, enables us to get there so quickly. On the top, in the numerator, we have got square root of 2 times by root 6 plus root 3. We could leave it like that, but actually we could tidy this up a little bit more as well. Say, okay, if we multiply through our bracket, root 2 times root 6, well, that's root 12. Root 12. We looked in a previous video at simplifying surds. Root 12, we know that that is root 4 times root 3, so 2 root 3. So we've got there 2 times the square root of 3. And our second part is root 2 times root 3, which we know is root 6, all over 3. Can we cancel down here? We've got a 3, a 6 and a 3. Well, no, we can't, because that number is 3, whereas these are square roots. Square root of 3, square root of 6, so there's no cancelling we can do there. That is our final answer.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.